This video is about expected value, probability trees, and Bayes' formula. Together, they are how you build a forecast when the future has more than one possible outcome, and how you revise that forecast when new information arrives. By the end, you'll be able to do 4 things: calculate an expected value and measure the risk around it, lay a forecasting problem out as a probability tree, combine scenario forecasts into a single number, and update a probability the moment new evidence lands using Bayes' formula. This matters well beyond this one module. Quantitative methods is around 1/10 of level 1, but expected value runs underneath a lot of what comes later: portfolio expected return and variance, the binomial model in derivatives, any scenario analysis you meet in corporate issuers. Learn it properly here, and you stop relearning it every time it reappears. Here is the idea to hold on to as we go. A forecast built as a single number has to be rebuilt every time the world changes. A forecast built as a tree updates itself. Start with expected value. An expected value is a probability-weighted average of everything that could happen. That word, weighted, is the whole idea. A sample mean treats every observation as equally important, and it looks backwards at data you already have. An expected value looks forwards, and it lets some outcomes count for more than others because you think they are more likely. Here's a company whose revenue could come in at 120 million, 100 million, or 80 million. You think the middle case is twice as likely as either extreme, so you assign probabilities of 25%, 50%, and 25%. Multiply each outcome by its probability and add them up. 25% of 120 is 30, 50% of 100 is 50, 25% of 80 is 20, 30 plus 50 plus 20 is 100. Your expected revenue is 100 million. Now measure the risk around that forecast. Variance is the probability-weighted average of the squared deviations from the expected value. Same weighting idea applied to how wrong you might be. The order here matters, and it is where people trip. You cannot calculate variance until you have the expected value, because the deviations are measured from it. Expected value first, always. Our deviations are plus 20, 0, and minus 20. Square them and you get 400, 0, and 400. Now weight them. 25% of 400 is 100. 50% of 0 is 0. 25% of 400 is 100. The variance is 200. Standard deviation is the square root of that, which is about 14.1 million. Do not memorize either of these. If you hold on to the idea that everything is probability weighted, both formulas rebuild themselves. Expected value weights the outcomes. Variance weights the squared misses. Now the part that makes forecasts updatable. Take an airline. Earnings depend heavily on fuel costs, so instead of guessing earnings directly, split the problem into scenarios first. There is a 60% chance of a low fuel cost environment this year and a 40% chance of a high one. Draw that as 2 branches. Inside the low fuel branch, earnings per share come in at $4 or $3, equally likely. So the expected earnings given low fuel costs is half of 4 plus half of 3, that is $3.50. Inside the high fuel branch, earnings come in at $2 or $1, again equally likely. Expected earnings given high fuel costs is $1.50. Those two numbers are conditional expected values. Each one is a forecast that applies only if that scenario turns out to be the world you are living in. To get your overall forecast, weight each conditional expectation by the probability of its scenario. 60% of $3.50 is $2.10. 40% of $1.50 is 60 cents. Add them and you get $2.70. That is the total probability rule for expected value. Now watch what the tree buys you. Fuel prices spike. You are in the high branch. Your forecast is no longer $2.70. It is $1.50, and you already calculated it. No rebuild. On your calculator, there is a shortcut most candidates never learn. On the BA2+, you can get expected value and standard deviation straight out of the statistics worksheet by entering probabilities as frequencies. Press second, then the data key. Press second, then clear work. Enter your first outcome, press enter, then arrow down. Now, instead of leaving the frequency at 1, enter the probability multiplied by 100. So a 25% probability is entered as 25. Repeat for every outcome, then press second, then the stat key, and arrow down. X bar is your expected value, and here you want sigma x, not Sx. That is the opposite of what you would use for a sample. A probability distribution describes the whole population of outcomes, so the population standard deviation is the correct one. Now the first trap, look at the top tip of the airline tree, the $4 outcome. What is the probability of that happening? It is not 50%. 50% is the conditional probability, the chance of $4 given that fuel costs are already low. To get the actual probability, multiply along the branch. 60% for low fuel times 50% for the $4 outcome gives 30%. Do that for all 4 tips and you get 30, 30, 20, and 20%. Those sum to 100, which is your check that the tree is built correctly. The exam will offer you the branch probability as a distractor because it is sitting right there on the diagram. So far, you have worked forwards from scenarios out to a forecast. Bayes' formula runs the same tree backwards. You observe something and you work back to which scenario you are probably in. Here is the setup. Across the companies you cover, 3 in 10 beat their earnings estimate in a given quarter. So your prior probability of a beat is 30%. Prior simply means what you believed before any new information arrived. Now, one of those companies raises its guidance. Should that change your view? You need 2 more numbers. Among companies that go on to beat, 60% raise guidance first. Among companies that do not beat, only 10% raise guidance. These are called likelihoods. They are the probability of the information given each scenario. Bayes' formula says the updated probability equals the probability of the information given the event divided by the overall probability of the information, all multiplied by your prior. Start with the denominator because it is the total probability rule you already know. The chance that any company raises guidance is 60% of the 30% that beat plus 10% of the 70% that do not. That is 18% plus 7%, which is 25%. Now put it together. 60% divided by 25% is 2.4. Multiply by your prior of 30% and you get 72%. That is the whole idea. You started believing there was a 30% chance of a beat. The guidance raise more than doubles it to 72%. That updated number is called your posterior probability because it comes after the information. 2 checks worth carrying into the exam. If that middle ratio is greater than 1, the information made your event more likely. If it is less than 1, less likely. And the updated probabilities across all scenarios must still add to 100%. Now the second trap, and it is the most tested idea in this module, 60% of companies that beat raise guidance. That is not the same as saying 60% of companies that raise guidance will beat. Those are different questions with different answers, and here they are 60% and 72%. The exam will hand you one and ask for the other. Before you touch the calculator, read which way round the conditioning runs. Now pause the video and try 1. 20% of the companies you cover get downgraded. Among those that are downgraded, 80% were flagged by your screen beforehand. Among those that are not downgraded, 10% were flagged. A company gets flagged. What is the probability it is downgraded? Pause here and work it out. The answer is 2/3, or about 67%. The easiest way to see it is with frequencies. Take 100 companies, 20 get downgraded, and 80% of those, so 16, were flagged. Of the 80 that are not downgraded, 10%, so 8, were flagged. That is 24 flagged companies in total, and 16 of them are downgraded. 16 out of 24 is 2/3. So let us pull the whole module together. Expected value is a probability-weighted average, and it looks forward rather than back. Variance is the probability-weighted average of squared deviations, so you always calculate the expected value first. A probability tree splits a forecast into scenarios, and a conditional expected value is your forecast if one particular scenario happens. The total probability rule combines those conditional forecasts weighted by the probability of each scenario. Multiply along the branches to get the probability of any single outcome. and Bayes' formula runs the whole thing backwards, taking new information and turning your prior into a posterior. If you remember one sentence from this module, make it this one. Work forwards to build a forecast and backwards to update it. Everything else here is arithmetic. Next up in quantitative methods is portfolio mathematics, where expected value stops describing one investment and starts describing how two of them move together. The full course and a free formula sheet are linked in the description.